Draw well-labeled axes on a squared paper, commonly known as a graph paper. Ensure the axes have a consistent scale and are strategically placed to give room for both object and image coordinates. Plot the object points P, Q, and R. For point P, move one step in the positive direction of the x-axis, followed by 2 steps in the positive direction of the y-axis. For point Q, move 4 steps in the positive direction of the x-axis, followed by 2 steps in the positive direction of the y-axis. For point R, move 1 step in the positive direction of the x-axis, followed by 5 steps in the positive direction of the y-axis. Using a ruler, let's join the points to form the object. Now, let's plot the image points P prime, Q prime, and R prime on the same graph. For point P prime, move 1 step in the negative direction of the x-axis, followed by 0 steps on the y-axis. For R prime, move 4 steps in the negative direction of the x-axis, followed by 0 steps on the y-axis. For point Q prime, move 1 step in the negative direction of the x-axis, followed by 3 steps in the negative direction of the y-axis. Now, using our ruler, let's join the points to form the image. Now, using a ruler, we join one of the object points to its corresponding image point. For example, Q, we are now going to bisect the line joining the object point Q to the image point Q prime. Position the compass at the object point Q. Stretch the radius of the compass to mark off 2 arcs on the opposite side of the line joining 2 and 2 prime. Without changing the radius of the compass, position it onto the image point. Mark off 2 arcs on the opposite side of the line joining 2 and 2 prime, and let them intersect with the first 2 arcs. Using a ruler, join the points of intersection of the arcs to form a straight line. This straight line is the mirror line, also known as the reflection line. Now, read off any 2 convenient points on the line to help in finding the gradient. That is, point A, 3, -2, and point B, 0, 1. Gradient, also known as slope, denoted by letter M, is equal to change in y coordinates divided by change in the x coordinates. M is equal to y2 minus y1 divided by x2 minus x1. So, in point A, 3 represents x1, -2 represents y1. In point B, 0 represents x2 and 1 represents y2. We substitute those points in our gradient equation, where we get 1 minus -2 divided by 0 minus -3, which gives us 3 in the numerator, because a negative times a negative is a positive, and -3 in the denominator. And when you divide 3 divided by -3, we get m equal to -1. Now we need to find a second gradient on the line. So we assume a point xy along the line and use it to get the gradient using any of the known points, say point B, 0, 1. We again use our gradient equation, that is m is equal to change in y coordinates divided by change in the x coordinates. Therefore, m is equal to y2 minus y1 divided by x2 minus x1. From the general point, x is our x1, y is our y1, and from point B, 0 is our x2 and 1 is our y2. Substituting in our gradient equation gives us m is equal to y minus 1 divided by x minus 0, from which we get our gradient m equal to y minus 1 divided by x. Given the fact that a line has the same slope or gradient, we equate the two gradients. So, gradient y minus 1 divided by x is equal to gradient negative 1. Then, we solve the equation to get the mirror line. So, on solving, we get y minus 1 equal to negative x. That is by cross multiplying, or you multiply x on both sides of the equation. On simplifying, we get y is equal to negative x plus 1, and this is the equation of the mirror line.